circular treat to share on Tuesday if you want bonus for the test on Wednesday. Oh, what? Go team.
How much bonus?
I don't know. It's like
This is
at least a couple points. Here we go. What is the formula from the page before? There is this thing called, you guys tell me so we can fill it in. There's this thing called the determinant of a 2 by 2, and we'll call him A, right? What is the formula for the determinant of A? AD, otherwise known as the main diagonal, minus BC, otherwise known as the opposite diagonal. Why one was cursive and one was print? I don't know. I don't want to do cursive with those. That's all. There you go. Now it's cursive. And then, what is the formula for finding A inverse of only sadly a 2 by 2? 1 over the determinant of A, which is the formula up above, times, what do we do to our matrix? Flip the main and opposite the opposite. This is the formula you were supposed to be using for the first however many minutes of class you had to solve this. So, question, what is the determinant of A and the determinant of B, because we need them to be able to solve for the inverse using this third way, which is the last way from yesterday.
6 and 3.
Main, 3 times 2, 6. Minus opposite, negative 2 times negative 1, 2. The determinant is 4. How do we use it? 1 over 4 times, flip the main, opposite the opposite, that is A inverse. Flip the main, opposite the opposite. Our goal to find the inverse without using the other 2 ways from yesterday. Flip the main, opposite the opposite. So who did I flip? 3 and 2. Who did I opposite the opposite? The opposite diagonal. I made them both the opposite sign. Now, could we box that and be done?
Yes.
Yes. Could we also say or and put the little 1/4 in? I suppose 2 over 4 is 1/2, 1 over 4 is 1/4, 2 over 4 is 1/2, 3 over 4 is 3/4. Both of them are correct. Representation of A inverse. Let me give you exactly 30 seconds to try B if you have not yet already using the same procedure. Go. Find the determinant, main minus opposite. That's doubly augmenting. That's when you go reduce to get the inverse. That's why. And there was the ABCD matrix multiplication. Quick example on this one. All right, is it my turn? Main minus opposite. Uh-oh. Anybody get a problem here? So then, when we come down here, what happens?
There is none.
Now, if you guys want to check to make sure you did it right, you would flip the 2 and the 3. You would opposite the negative 1 and the 6 to be positive 1 and 6. When you go to solve, what happens? It's undefined. 1 over 0. That doesn't exist, right? So then what do we say? A inverse does not exist. Now, what snazzy vocab word from yesterday describes a matrix with no inverse? Singular. Non-invertible, I guess we could use, but kind of awkward. Singular. A is a square matrix whose inverse does not exist. And how were we able to know that? His determinant was 0. So anytime a determinant is 0, the matrix is not invertible. Ricky.
Go to the back.
Go back. And I think, actually, did we write this down? Yes. Aha! You guys see this thing maybe you wrote down yesterday, maybe you didn't? A is invertible if and only if AD minus BC, aka only if the determinant of whatever matrix it is does not equal 0. If the determinant is 0, that inverse is not going to exist. And the nice thing is, that's of any size inverse. This last clue, not just 2 by 2s, this last clue helps us out with 3 by 3s, 4 by 4s, 5 by 5s, and all the rest. If the determinant is 0, no inverse is going to exist. Kiddos, grab out your graphing calculators. We did not get to look at yesterday because you've been practicing with your calculators here and there with matrices. Let's see how/where you can find an inverse on your calculator. Just because it is good to know how to use your calculator. We'll answer this question. Then we'll zoom ahead. We have one quick application of section 8.3 just to make sure you guys got it last night. Where am I? I don't know. Let's go ahead and put in, let's put in that last matrix we were working with. How can we use our grapher to find the inverse? You don't necessarily have to write this in your notes. But let's try to find the determinants of each of these. So put in A and put in B. Let's see what the calculator is going to do. With them, how it's going to show us a non-existent inverse. First of all, how to find the inverse. Alright, so you guys are putting in the matrix into your calculator, so will I. Get rid of this little guy so I can see. So I have matrix A in there. If I was to need matrix B, let's go edit, edit, edit. Who has found how to find an inverse yet? Oh, it's not in the matrix math menu? Everything's in the matrix math menu, isn't it? REF is in there, REF is in there. Actually, even row operations are in there. Has anybody seen the row operations? P.S. It'd be so much harder to do in your calculator, so please don't start thinking about doing that. It'll be a mess. You can find dimensions using the math menu. You can find the identity matrix. That's weird. You can randomize. You can augment. You can. This is some. That's weird. Ooh, row swap, row add, row multiply. You can do row operations here at the very bottom. But I did not see an inverse, and the reason why is what Nathan just said. In order to find. Now wait, hold on. You guys see this little -1 button? I need to make sure you fully understand him. If I do 2 to the -1, what does this button mean with any sort of number that you put into it? It's reciprocal. The reciprocal of 1/2 is 2. The reciprocal of 4 is 1/4. The reciprocal of 2 is 1/2. It takes the reciprocal, okay? So it's a reciprocal button for numbers. However, the programmers for your graphing calculator were super cool, and they're like, oh, you know what? For matrices, they might want an inverse button. Now, I know it's a reciprocal button for numbers, but for matrices, they programmed it to be an inverse button. So once again, this can mean inverse with notation, or it could mean reciprocal. It never means both. Reciprocals and inverses are different. With matrices, they programmed it to mean inverse. Ready, set, what's the inverse of A? Ew. That's gross, but is it right?
No.
0.5, 0.25, 0.5, 0.75. You guys remember how we can make it look pretty? Math, fractions. It can do that. If I hit enter enough times. There we go. Check. Now, how about matrix B? We figured out, or we think that that one is singular, that the inverse doesn't exist. Let's try a little -1 button right again. X to the -1 below math. Singular. Oh, look, it knows our vocab. Go team. All right. Here we go. Quick application. Instead of writing about it, let me just show it to you. Sound good? Instead of writing about it, let me just show it to you. How can we, this is one of the types of problems in your homework. We're actually going to grade the homework tomorrow just for sake of time. We need to get in section 8.4 today. Start it. We might not finish it. Might have to finish a little bit tomorrow. Then start 8.5 tomorrow. Finish Monday, which lets our test review be Tuesday as we eat some pie or other circular snacks. Yeah, Oreos. Please. Don't everyone bring Oreos though. That'll be boring. Okay, coming back. Someone bring something circular and not sweet.
What?
Need sweet and salty, otherwise it's going to be rough.
What? So you just want me to bring like a round salt shake?
No, thank you. Unless you bring fruit.
put salt on the fruit.
Some people do. I don't.
Doesn't
I
that
was
like
trying to
pull
say
all the
something.
moisture out?
Cuts out the acidity. Okay. That's why people in third world countries. Kiddos, here's Dilio. How do you solve this? How do you solve this?
Put it
Coming
in
on
the
back.
matrix.
No.
Oh.
How do we solve using the inverse like the directions tell us? Maybe I should have said that instead, huh?
Oh.
Okay, so let's go ahead and make a coefficient matrix. 0.2, negative 0.6. We've already seen how you can pull away the variables from the coefficients. We have this guy times this guy equals this guy. What I basically just did is I factored out the x to be the first of a column, the y to be the second of a column. This x also goes to the first of a column, this y goes second of a column. However, we also kind of talked about how you can take the coefficients, and then you can take the variables, and then you can set it equal to the constants. If you want to double check, cross down, it works with matrix multiplication. Okay, long story short. When we have something like this with numbers, let's say we had 2x equals 4. How would you solve for x? If you had something numerical in the place of a and b, how would you solve for x? How? You would divide by 2, right? You would do the inverse operation of the multiplication, right? And what's the inverse operation of multiplication? Division. And what you do to one side, you do to the other exactly the same, right? Now, question. Elaine Baylor, paying attention to us? Focus in. Instead of undoing like by division, matrices are their own little beasts. We can't undo with division, but what can we undo with?
Inverse.
We can multiply the inverse by a, and the inverse by a ends up basically becoming the identity matrix, which multiplied by x just leaves x alone. But what I do on one side, I must do on the, oh, no big deal. With numbers, it doesn't matter. I just write it over here. Am I right?
No.
No. I am horribly wrong. Matrices cannot multiply both directions. A times B does not equal B times A. So A inverse times A should not be mimicked by multiplying B times A inverse. What is the only proper way to solve? Do A inverse on the left of B, just like you did A inverse on the left of A. Now, how do we apply this? Kiddos, didn't we learn how to find the inverse of a matrix using our calculator? Okay. So if this is A, I want you to find for me A inverse. And then what are we going to do? It said A inverse.
Multiply it by b.
Multiply it by B. And guess what we're going to get? Our X matrix, which will give us our X and our Y. This is our big X, our variable matrix. Okay? So I'm grabbing out my graphing calculator just to show you what's going on. We're throwing in 2, and some of you already have. Thank you, thank you. Unless I need to quit first. There we go. Second, matrix. Let's go on over and let's edit. Matrix C. I'll just edit A because we don't need it anymore, right? We have our 0.2. We have our negative 0.6.
You're still.
David Austin,
You're
focus.
still in the dimension.
Thank you. I'm distracted by troublemakers. Might contribute from time to time. Negative 1. The things you think I don't hear. Shush. Okay, coming back. If we find our second matrix and we have our little A dude that we just plugged in, and if we find his inverse, there he is. Ew. Let's not write him down. Then let's multiply. Here, you know what? Haha. Oh, I can't do that. This isn't smart. Notebook. Never mind. Pretend that guy's there. And then we need to multiply him by matrix B. Struggle. Who's matrix B? The other dude. What order is that matrix?
1,
2
2 by 1.
2 by 1.
2 by 1. Good. 2 rows, 1 column. Just making sure that we're still keeping track on the orders. And we end up with a 2.4 and a negative 8.8.
6 and negative 2.
And when we quit, and when we throw in our answer times, do you guys know that second over arrow gets you to the end of the line? I learned that the other day. It's kind of fun.
Oh,
And second back arrow gets you to the beginning of the line.
okay.
Pretty cool.
That is
Those of you that knew that.
When you have like a big, long,
Yeah, right?
irrational decimals.
6, negative 2. Dun, dun, dun. If you guys want to, you can plug in 6 and negative 2. X is equal to 6. Y is equal to negative 2. If you double check in the original, guess what? It works. Jason. Okay, don't get lost.
All order for him.
Now we're done with section 8.3, which for us I think is homework number 51. A little bit off last year's schedule. I don't really know why. Alright, section 8.4, we're supposed to start it. The nice thing is, it starts exactly where the last section leaves off. We get to review that main minus opposite determinant formula. Let me full screen. So you guys should be able to fill in that formula right away. Because we already talked about the determinant of a 2 by 2. So maybe you can guess where we're going. If we already know the formula for the determinant of a 2 by 2, maybe we're going to determinants of other sizes, other dimensions, other orders. AKA not just 2 by 2s, but 3 by 3s and 4 by 4s and 5 by 5s. Just kidding. Probably not one half it. Maybe. But we're starting with a 2 by 2 because he's nice and easy. And then we're building to a 3 by 3. Maybe even a 4 by 4. Kind of like some other things in math. There's a trick. Well, there's a formula for a 2 by 2. There's a trick for a 3 by 3. And then there's a process, a procedure, a formula for 4 by 4s and above. So we're actually going to learn the formula on something smaller like a 3 by 3. And not just use the trick. But we'll see both. First of all, what have you guys filled in for your formula? Using the words main minus opposite, the main diagonal minus the opposite diagonal. But yes, it is going to be AD minus, bless you, BC. Delayed response. AD, what I call the main, minus BC, what I call the opposite. Now you guys have already seen me write, at least a couple times, DET of A, and that's actually kind of how the calculator puts it as well. You guys saw it sometime earlier. Jason, we're on this new section, new sign. You can write DET with an A. Capital A standing for a matrix. You can also use absolute value bars. Does not mean absolute value, it's just a notation. So when you see that notation, you can also just think determinant. And then the other way is that we could actually take whatever matrix capital A is, like the entire matrix, and instead of putting that in brackets, we can put him in the same absolute value bars. At some point, one or most of you will get confused by notation, so make sure you have this written in your notes. If you see, once again, the absolute value bars around a matrix's name, or around a matrix, it is saying find that determinant. Find the determinant. Solve for the determinant. Cool beans? change it up. We ready? Set and go. So practice your main minus opposite skills. I don't have my 3 screen button. Practice your main minus opposite skills. I'm going to practice the new notation too, just so you guys get used to seeing it. How'd you guys do? Oops, it didn't show. Did we get there? Come on, SATs are coming.
No.
Can't make little mistakes.
Tomorrow.
I'm just referring to the mental math, not to the determinants of matrices. Probably not on there. Although sequences and series might be. Sadly, they're not until our chapter 9. But you'll see it before the end of the year if you take the SAT, say in the summer or the beginning of next year. Double checking your formula real fast if you can't find it. Remember, main minus opposite, right? 4 minus negative 3. Main minus opposite, 4 minus 4. Hey, what does it mean if the determinant is 0? Good. B is singular, which means B inverse does not. Everyone? Oh, Ricky stole it. Where were the rest of you?
Exist.
Focus on your mental math. Thanks. B inverse does not exist. Main minus opposite, 0 minus 3 halves times 2, in case you didn't do that. Mental math, remember, if it's just 2, 2 over 1, that can reduce. Are we cool? All right, let's keep going. Those are 2 by 2s. Any quick questions? If you don't have a 2 by 2 down, it's going to be rough. If you have a 2 by 2 down, we can do it. We okay? If we're okay, give me a thumbs up. All right. Just making sure you weren't just ignoring me. Okay, so other determinants. Let's start with the easiest one. If you have a 1 by 1. Other determinants. Let's start with the 1 by 1. You only have one element. You can't do a main. You can't do an opposite. Guess what? His determinant is himself. Well, that's easy. So you're rarely going to see it because it isn't really. Well, first of all, 1 by 1 matrices are very rare. Determinant of a 1 by 1 is technically himself. Determinant of a 2 by 2 is a main minus opposite. Determinant of a 3 by 3 is a little bit more complicated, but there is a trick. There is a trick. And I'm going back and forth between whether to show you the trick first or whether to show you the process that works for all. Let's do the trick first. Hold on for just a second. I need you guys to write down matrix A, find the determinant. However, ignore all the stuff below for right now. Okay? Ignore all of that. Write down matrix A. But I don't just want you to write him down once, I want you to write him down twice, right next to himself. Copy him twice. Think A squared, but don't multiply. Think A squared, but don't multiply. This is called the 3 by 3 trick, and the sad thing is it only works with 3 by 3s. Hence why it's good to show you, but most of you will probably end up using the procedure that's kind of shown here below with the circles and the lines and all that jazz. Okay, you guys have A equaling and I told you guys to go ahead and write them twice, right? Now, I don't like the spacing of the last row. Let me go ahead and rewrite them one more time. Only works for a 3 by 3. Wait, who does this work for? Anybody else? Just a 3 by 3? Okay. Just making sure we're all on the same page. Remember how a 2 by 2 is main minus opposite? For a 3 by 3, if we just did main minus opposite, would we get everybody? No. Only works for a 3 by 3. So instead of 1 main minus 1 opposite, we actually do 1, 2, 3 mains minus 1, 2, 3 opposites. Now wait, hold on. Does 0 go to someone? Yes. Does 2 go to someone? Yes. Does 1 go to someone? Yes. Does 4 go to something? Yep. Does 0 go to something? Yep. Does 1 go to something? Yep. Wait, what about 3? Don't worry. He's been covered.
This is weird.
So ready?
No.
You would do 0 times negative 1 times 1 plus, that's 1 main, 2 times 2 times 4, second main, plus 1 times 3 times 0, third main. Oops, I did the wrong one.
Wouldn't it be 1 times 3 times 2? Oh, you're going that way.
Yeah, I'm going diagonal.
Oh.
That's main, 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 minus opposite, starting at the 4, 4 times negative 1 times 1, plus 0 times 2 times 0, plus 1 times 3 times 2. And I've gotten opposite, opposite, opposite.
Wow.
Which ends up equaling. Now I'm going to go ahead and distribute my little negative because you guys know me. Don't want to kill any seals. Save the environment and all that or something. Just kidding. Save your grades. So, coming back. 0 plus 2 times 2 is 4. 4 times 4 is 16. True. Plus, that's a 0. Minus 4 times negative 1 is negative 4. With a minus is plus 4. Minus 0 minus 2 times 3 is 6. Final answer for the determinant is 20 minus 6 is 14. Now, pause. Can your calculator find a determinant?
Yes.
Yes. How? Using the math menu. Can't do inverses. Hey, look, DET. I think that's a thing, right? If I edit and I edit, sorry, I switched my screen. A to B instead of 3 by 3. Happened to the 1. There we go. Go to our second matrix, go to our math. Determinant of, go to our matrix, check out A. Dun 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 dun. Well, that was nifty and all, right? However, didn't I say this only works for who again?
3 by 3.
Aw, bummer. So, 2 by 2, main minus opposite. 3 by 3, main, 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 minus opposite, opposite, opposite. Don't forget to distribute your minus, aka your negative.
So that's it.
But what about all the rest? There's another way. There has to be. The 4 by 4s and above. So let's use this 3 by 3. Let's use this matrix 0, 2, 1, 3, negative 1, 2, 4, 0, 1. And let's say, okay, there's a trick, but what is the method that will work for all higher order matrices? All square higher order matrices. I want you guys to write matrix A one more time. And I want you to rewrite it, I know it's annoying, 3 times.
3?
Yes! Trust me!
Why
Stop
so
whining!
much?
You can whine for a half second and I shouldn't hear it. Just do it again.
Missing 1.
This should be the
Well,
Yeah.
that was like a third.
Yeah, that was. Third?
You should be probably the true. What if we
It's internal. And you're learning the life skill of Get over it. All right, so
Ooh.
that was not directed to anyone.
I think
That
I'm
was
gonna
a good
tell
life
myself
lesson.
no, Miss D.
I wrote it
It's over.
Some things are important to dwell upon, and some things are not.
Such as my teacher's old roast me, so now I'm gonna drink bleach.
That's exactly what you're not supposed to dwell on.
What's that popcorn board?
Yeah, it's
It's been talked about. It's been talked about.
Your book's down 1972.
Really?
Oh my goodness. Ricky. Ask me later, I'll tell you the whole story about how we talked about being in class. Okay, so.
Wait, in this class?
Yes.
Was
Chill,
that the
Ricky.
bathroom?
Chill.
Oh,
Chill.
do you go to that yet? That's why. You would have remembered it. Someone found it, Austin found it in my room, left it in my room, and we're all like, who are these people? Okay, so.
I know who it is.
I want you guys to follow the pattern. The 0 is circled, stuff is crossed out. The 2 is circled, stuff is crossed out. I want you to follow the pattern. What do you think the third one would have? Go. Follow the pattern.
One is circle. One is circle.
The 1 is circled? Really?
One is
Oh,
down.
wow.
Aren't you guys smart?
Do you multiply these things?
Now, I haven't told you exactly what to do with it. I just saw if you could follow the pattern, and you could. That's cool. How do we use the pattern? Let me show you. Ready? To find the determinant of A. I'm going to show you the pattern first, show you the complicated formula that describes the pattern, and then we'll see if we can repeat the pattern. Ready? The 0 is going to be multiplied by absolute value bar, aka determinant. The 2 is going to get multiplied by absolute value by bar determinant. Don't worry, take it on faith and see if you can follow the pattern for the last one.
I guess.
Follow the pattern. Don't stress. You haven't learned a formula yet. You haven't learned a theorem or a proof. See if you can follow the pattern. 0 times the determinant of who's left. 2 times the determinant of who's left. So you guys tell me, what's the last one?
One.
One.
Negative 1 for 0.
Got it.
My girl.
Jason. Now, hold on. There's one extra piece I have to add in. This is a 3 by 3, right? We always start with a positive. Just go with me for a second, all right? These little thingamabobs, each one separately is called a minor. M-I-N-O-R. It's called a minor of a matrix. And it is formed anytime you go across one row, or you could form minors going across one column. It could be any one row, it could be any one column. You just have to do it for each element in said row or column. So I've done the minors for the first row. However, this will not solve for the determinant until I make them cofactors. And I cannot make them cofactors until I think about this little chart of signs I'm about to make. And what do you notice about the pattern of the chart of signs? What's going on with the signs? Alternating, and what did I start with at the very top? Start with positive and then alternate. Now, what does this mean? This positive is going to go outside the 0. This negative is going to go outside the 2. And this positive is going to go outside the, where is he? There he is. Outside the 1. So I do not randomly change the sign of the number that's there to be what's the sign in the chart. I add the sign in. And then, how do I solve? You ready? 0 times anybody is 0. Wait, pause. 2 times the determinant, 3 minus 8, plus 1 times 0 minus negative 4, ends up being dun, 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 determinant. We almost made it all the way through 8-4, believe it or not. We'll finish it tomorrow. Finish 8-3. We'll grade it tomorrow. Start 8-4. Bye, guys.
No idea.